Recommendations for electronic circuits prototyping. Use a 30-watt soldering iron to solder your component in Vero board. Use a soldering iron and sponge with water to clean the tip of the soldering iron. Use a good quality soldering wire to wire up your prototypes. Use a proper wire wrapping wire to wire up your prototypes. Use soldering fume extractor to protect yourself from the fumes of the soldering wire. Use a good quality tin coated Vero board for your prototyping. Here we have the final shape of our RTU, which we have designed during our last 48 sessions and in 2 courses, that is basic course and the advanced course. Now our RTU is completed and we have interfaced different devices with our RTU, that is 2 lamps of 220 volt AC. We will drive these lamps with these 2 relays, that is relay 1 and relay 2. We have also connected a 220 volt fan with our triac circuit. We will switch on and switch off the fan with the help of triac circuit. We have also interfaced 8 LED with our RTU. We have interfaced 20x4 LCD with our RTU, and we have interfaced a 4 multiplex 7 segment display with our RTU. We have interfaced a buzzer with our RTU. We have developed a circuit to interface the PT100 sensor with our RTU, and we have developed a circuit to convert the PWM signal into analog voltages. We have interfaced 4 switches with our RTU. First we'll understand the complete wiring diagram of the devices which we have connected with our RTU. Then we'll write a serial communication program to monitor and control the status of different devices which we have connected with our RTU over serial link to a master terminal unit. And here we have connected a Picket3 programming interface with our RTU. Now we'll start writing our serial communication program between master terminal unit and remote terminal unit which we have designed in our course. Here we can find a wiring diagram of different devices which we have connected with our RTU, that is 2 lamps of 220 volts and a 220 volt fan. And here we can see we have connected a PT100 sensor with our RTU, and here we have the analog output, that is 0 to 10 volt from PWM to analog conversion circuit, and we have connected a buzzer on port RC0. We have connected a triac on port RE1. We have 2 analog inputs from variable resistor which we have connected with our RTU. We have connected 8 LEDs on port B of the microcontroller. We have also interfaced a 20x4 LCD display with the microcontroller, and we have interfaced a 4-digit multiplex 7-segment display with the microcontroller. And here we have the power supply selection jumper for LEDs, LCD display and 7-segment displays. And here we have the connector interface for Picket3 programmer. Now we'll understand the electrical wiring diagram of different devices which we have connected with our RTU. Here we can see we are using a 220 volt AC power supply to energize our remote terminal unit. And we are using a step-down transformer to develop different power supplies, that is plus 12 volt, minus 12 volt and plus 5 volt. Here we can see the neutral supply is directly connected with the 2 lamps and the triac circuit. And the phase of the 220 volt power supply is going to relay 1, relay 2 and the triac circuit. If relay 1 will be energized, then green lamp will be on. And if relay 2 will be energized, then blue lamp will be on. And if we'll switch on and switch off the triac circuit, then we can control the status of the fan which we have connected with the triac circuit. And here we can see we have connected 4 switches with the microcontroller from port D4 to port D7. Here we can find an interface link between RTU and MTU. Here we have a computer as master terminal unit, and we have our remote terminal unit which we have designed in our course. We have created a serial link between master terminal unit and remote terminal unit over RS232 to USB conversion interface. Because in modern days computers, RS232 interface is not available. That's why we have used a RS232 to USB converter interface, and we have developed a circuit of RS232 interface using MAX232 IC. So our RTU is capable of communicating over RS232 link. RS232 is a simple electrical level conversion interface, and we can communicate between MTU and RTU using different software buses. And now we'll discuss the serial communication prototypes of micro C compiler that we will use in our serial communication program. Here is the first prototype, that is UART1 Initialize at a baud rate that is 9600. We can change the baud rate according to the requirement of our application. Here we'll use 9600 baud rate, that is 9600 bits per second. And here we have the second prototype, that is UART1 data ready. If the data is received, then we can take different decisions on received data. And here we have 2 more prototypes that we will use in our program, that is UART1 read text and UART1 write text. In UART1 read text will receive the character string in a variable, that is output. Here we have the variable, that is output, and here we have a delimiter, that is OK, and the number of attempts are 10. We can replace this delimiter with any other character as per our choice. And in the prototype, that is UART1 write text, will transmit the string of the character that we have in our output variable. We'll use these 2 prototypes to receive and transmit the text between master terminal unit and remote terminal unit. We will also use UART1 write prototype to write any character to the UART terminal. We will use the string copy prototype to separate the subtext from the main text which we have received from the USR terminal. This prototype copies the first 4 characters from the string subtext to the text. We will also use a prototype, that is string comparison, to compare 2 different text messages. This prototype compares the first 3 characters from the string text with the string text sub and returns a difference. If the text sub and the text will be compared, then the value of the integer, that is res, will be 0. And now we'll discuss our own design communication protocol to communicate between Rtu and Mtu. Here we have our first command, that is LED000 and the percentage sign. LED is a command to write the data on 8 LEDs, and the number 000 represents the data from 0 to 255. And here we have the delimiter character, that is percentage sign. We will use this command to turn on and turn off the buzzer. BUZ means to write the data on buzzer, and the number 0 or 1 represents the on and off status of the buzzer. If the number will be 0, then the buzzer will be off, and if the number will be 1, then buzzer will be on. And here we have the delimiter character, that is percentage sign. We will use this command to switch on and switch off two relays. RLY command will be used to write the data on relays. First number represents the relay number, and it can be 1 or 2, as we have two relays, that is relay 1 and relay 2. And the second number represents the status of the relay. If this number will be 0, then relay will be off, and if this number will be 1, then relay will be on. So we can control two relays by using this command, that is relay number 1 and number 2. And here we have the percentage sign as delimiter. We'll use this command to switch on and switch off the triac. TRC stands for triac, and the number 1 or 0 represents the status of the triac. If this number will be 0, then triac will be off, and if this number will be 1, then triac will be on. And here we have the delimiter, that is percentage sign. We will use this command to read the status of the switches. The string SHW will be used to read the status of the switches, and here we have the percentage sign as delimiter. We'll use this command, that is ANA, a number and the percentage sign, to read the analog channels from 0 to 3. The string ANA will be used to read the analog channels, and the number 0 to 3 will be used to read the channel number, that is from 0 to 3. And here we have our final command to write the data on PWM port, that is PWM000 and the percentage sign. The text string, that is PWM, is used to write the data on PWM port, and the number 000 represents the value of PWM control, that is from 0 to 100%. It's the duty cycle of the PWM signal, and here we have a percentage character as delimiter. Now we'll implement these commands in our serial communication program to communicate between master terminal unit and remote terminal unit. Here we have connected a RS232 to USB converter circuit with the RS232 port of our RTU, and the second end of this interface is connected with the computer. Now we'll start writing a serial communication program to monitor and control different devices connected with our RTU from the master terminal unit. We will start from a new project. We'll go to the project, new project, OK, standard project, and the project name will be RTU control, that is RTU control, and the project folder will be in micro C projects. We'll go to the serial projects. OK. Device name is PIC16F877A, and the device clock frequency is 10 MHz. OK, next. Finish. Here we have our main program starting from void main. Now we'll add some comments and assignments in our program. Here we have assigned the name to our project, that is RTU control project. OK, save. And now we'll add some ports assignments. As we have connected 8 LEDs on port B of the microcontroller with the help of ULN2803. So first we'll assign the name to the port B of the microcontroller. So here we will write, that is define LED PRT, that is LED port, and LEDs are connected on port B, so we'll write port B. We have interfaced the buzzer on port RC0 of the microcontroller, and now we'll assign the name to port RC0. So here we will write, that is define, that is buzzer on port RC0, that is port C0. Relay 1 is connected on port RC4 and relay 2 is connected on port RC5. Now we'll assign the name to the ports, that is RC4 and RC5. So here we will write, that is define RLY1 port C4, and we'll define relay 2 on port RC5, that is port RC5, and here we can check we have interfaced a trike on port RE1. Here we can check we can control the status of the trike from port RE1. Now we'll assign the name to port RE1, and here we will write, that is define trike on port RE1 . Then here we can check we have connected 4 switches from port RD4 to RD7. Now we'll assign the name to the port D of the microcontroller. So here we will write, that is define SWPRT, that is switch port, and the port is port D. So here we will write port D. We can add more port assignments as and when required in our program. And now we'll assign the directions to the port in our main program. So here we will write our main program. Port B of the microcontroller is used to drive the 8 LEDs. So we'll configure the port B as output port. So here we will write trace B equals to 0. And here we will add a comment. Port B is configured as output port, and now we'll assign the direction to the buzzer port. So here we will write, that is port C0 is configured as output. Now we'll assign the direction to the relay ports. So we'll write port C4 is configured as output port. Now port C5, that is port C5 is configured as output port. And now we'll assign the direction to the trike port, and we'll write port E1 is configured as output port. And now we'll assign the direction to the switch port, that is trace D equals to 11110000. As we can see from the schematic that lower nibble of the port D is configured as output port, and the upper nibble of the port D is configured as input port because it is connected with the switches. So here we have assigned the direction to the port D in binary format, that is lower nibble as output and the upper nibble as input, and here we will add a comment. Lower nibble of port D is configured as output and higher nibble as input. And here we can see from the schematic that we have connected a test LED on pin number 18 of the microcontroller, that is port RC3 of the microcontroller. So we'll also assign the name to the port RC3 of the microcontroller, and here we will write, that is define test LED on port RC3, and now we'll initialize the ports that we will use in our program, that is LED port, buzzer, relay 1, relay 2, trike, test LED and switch port. So here we will write, that is LED PRT equals to 0. So here we have initialized the LED port to 0. Now we'll initialize the buzzer port, that is buzzer equals to 0, and we'll also initialize relay 1 and relay 2 to the 0 value. So we will write relay 1 equals to 0 and relay 2 equals to 0, Here we can see from the schematic that the logic for triac circuit is active low. If the signal that is FAC will be low, then the triac circuit will be on. So we'll set the signal that is FAC as high, and here we have given the name that is triac to the FAC port. So here we will write that is triac equals to 1. It means initially triac circuit will be off, and here we can see the logic of test LED is also active low. So we'll set the port RC3 as high to switch off the test LED, and here we will write that is test LED equals to 1, and now we'll initialize the switch port. Here we can check the lower nibble of the port D is connected to the anodes of the 7-segment display, and the higher nibble of the port D is connected with the switches. And we can see from the schematic that the logic of anode selection is active low, and we can check the logic of all 4 switches are also active low. So we'll assign the value that is 255 to the port D. So here we will write that is SWPRT equals to 255. Here we have initialized all the ports that we will use in our program. Now before writing the while loop, we'll initialize the serial port. For this we'll go to the help, and in help we'll go to the micro C Pro for PIC libraries, and here we'll go for UART library. And here we can check from the sample program that how to initialize the serial port, that is UART1 initialized for 9600 baud rate. So we'll copy this command from the example program with the delay prototype, Control C, and we'll paste the prototype here in our main program, that is Control V. And now we'll write the while loop of our program, that is while 1. And we'll write the while loop between these two braces. In while loop, first we'll call a subroutine, that is serial data read routine. So here we will write that is serial read routine, and we'll write the serial read routine before main program. So here we will write that is serial read routine, and we'll write the serial read routine here, that is void and we'll write the serial read routine between these two braces. For this we'll go to the help once again, and here we can find 3 prototypes, that is if UART data ready, UART read text, and UART write text. We'll copy these 3 prototypes from the sample program, Control C, and we'll paste these prototypes here in our serial read routine, that is Control V. Here we can check we have initialized the serial port, that is UART1 for 9600 baud rate. So we'll add a number that is 1 in our prototypes, that is 1. And now we'll define a variable to receive the data from the USR terminal, and here we can find a variable with the name that is output. We'll define a new variable, and we'll define the variable before serial read routine. So here we will define that is variable assignments, and we'll define the variable here, that is character, and the name of the variable is receive string, that is RECSTRG, and we'll define the length of the string as 20 characters. So here we will define, and now we'll replace the variable that is output with our newly defined variable that is receive string. So we'll copy this variable from here, Control C, and we'll replace this variable that is output with our new variable, that is Control V. We'll also assign a new delimiter, that is %sign. And now we'll compile our program and we'll observe the result of our program on our RTU. Here we can check our program is compiled successfully. We will go to the file, import hex, and here we have our new hex file, that is RTU control. OK, write. Now we'll go to the USR terminal of micro C compiler. We will go to the tools, USR terminal, and here we'll select the COM port 3. The baud rate is 9600 bits per second. Now we'll connect the COM port 3, and now we'll send the string to the microcontroller with the delimiter, and the microcontroller will send back the string to the USR terminal. So here we will write that is A, B, C and %, and now we'll send the string Here we can check we have received the same string, that is ABC. We have tested our basic program to transmit and receive the data from the microcontroller. Now we'll develop our complete program to communicate with our RTU.